Hey geometry students, we are going to continue on with 17.1 notes today, part 2. We are going to have out page 244 and be going to page 246. So make sure you have those pages out. We are going to continue where we last left off yesterday, where we're now going to be considering a center of dilation. So let's go ahead and zoom in up at the top and see what a center of dilation is. So a center of dilation, if we look in the margin on the left side, is a fixed point about which all points are enlarged or reduced. So yesterday, in each of Kate's layouts, the center of dilation was the origin. Now she considers some dilations where the center is not the origin. So just like we see on a coordinate plane usually, the origin is our center where it's easy to enlarge and reduce different shapes when that is our center. Now what we're going to do is something that's a little bit harder. We're going to have our fixed point where all the other points are enlarged or reduced around. It's not going to be at 0, 0. So Kate wants to dilate triangle ABC with a scale factor of 2, so we want to double it. But we also want a center of dilation. It's going to be at the point -2, 4. So let's find that point. That point is actually right here where point A is. So what we're going to realize above is that, what we're going to realize below is that when the origin is not at our center of our dilation, like 0, 0, we need to subtract the coordinates of our center of dilation from the coordinates of the pre-image. Then after that, we're going to multiply this difference, the subtracted difference, by the scale factor, and then add the coordinates of the center of the dilation. So this is a pretty important paragraph right here that's going to tell us, okay, when our center is not 0, 0, it's going to be a little bit more difficult, but we have a couple steps that can show us how to do this. If we continue to scroll down and look at the margin again, it talks about these steps a little bit more of what we can do. It says when the center of the dilation is not the origin, there's something else that we can also do as well. We can translate the center of our dilation to the origin. So we can figure out how we're going to change the center of the center of dilation to the origin. And then we're going to find the image of the vertices. Then we're going to perform our dilation and then write down the coordinates of the second image. So that dilation is either getting bigger or smaller. Like in this problem, it's probably going to get bigger since it's times 2. And then after we multiply, that dilation by 2, we multiply that figure by 2 for our dilation, we then translate the second image back. So we're going to translate it back so that way this is now the center of dilation again. Now, this method, when explained, sounds a lot more complicated, but we can actually take this and make it into a series of simple steps. And this is actually the method that I am going to be focusing in on right here. So that's something that we can kind of refer back to. Again, I'm going to be making some simpler steps at this as we go through it. So I'm going to go down a little bit, have a little bit of space in our margin, and I'm going to go through each of the steps, making this part up here a little bit more simple. Now, if I were you, I would also suggest to write this down maybe on a different sheet of paper if you don't have enough room. In fact, I'm actually going to write it down probably on the right side because I have a little bit more space over here. So that way I'll have all the steps right here, and then we can actually perform the dilation with a different center than 0, 0. So before we start, what it tells us, if we have a point xy that lies on our pre-image and we know our figure is dilated with some type of scale factor k with AB as our center of dilation, what we're going to realize is the corresponding point on the image is going to follow this pattern. So this goes a lot with this up here as well as this. So we're trying to kind of simplify it, bring all ideas together. We're going to see that, yes, we're including our center of dilation for our x value is A, for our y value is B, and we're going to see it's incorporated not just once but twice into each of our coordinates. We see we have x and y, so we end up actually subtracting the center of dilation for the x and y value. We multiply it by the scale factor, k, and then we add it back in. So it goes along with those directions as well as these right here. So to take this idea into full effect, I'm going to use a little color coordination. So go ahead and follow me on this. So we are going to have the steps to go from point XY to the following. So like I said, we have our coordinates. What we'll do is we're going to have X and Y. What we first need to do is we need to move our center of dilation to the origin. So what happens is I subtract out the A value and the B value for my X and Y. Then that whole quantity of each of those is going to be multiplied by the scale factor K. So we multiply each of those by a scale factor K, increasing it or decreasing it. Then after that, what we have to do after we, dilate by the scale factor K is that we have to add back the initial center of dilation. So it's kind of, going back and saying, hey, wait a minute. We then have to add back an A, add back an B, move it and shift it on over. So we're going to talk about each of the steps as we go through it. So first step 1, right? We have to translate the center of dilation, so I'm going to call that COD or COD, to the origin. And the way we're going to do this is by subtracting. So we're going to say by subtracting the center of dilation from the X and Y values. Now, I know this might seem wordy and complicated, but what we're saying is just this blue part here. We're moving our center to the origin by subtracting X and Y values, right? Our given center of dilation from our X and Y values. All right, the next after that, step 2. All right, we are going to dilate. Really, essentially, we're going to multiply by scale factor K. Then our last step, step 3, is where we have to add back the initial translation, meaning we have to add back what we subtracted out before for our center of dilation. Again, a little bit of complicated steps, but honestly, it really explains this pattern that we're working with. Now, I decided to add at the end instead of at the beginning as used right here. Either way is fine. I just, I could have put the K afterwards. I could have followed the same lineage. We can actually use this formula to explain what we're going to be doing and how to show it. So I didn't just want to give you a formula. I wanted to explain, okay, what we're actually doing and why it makes sense. So let's actually look at questions 15 through 17 right now. and see what we can actually do. And something else we can do is we can go back up and refer to our image up here, because we might have to, draw our picture at some point. So looking at number 15, it says, what are the coordinates of the vertices of our pre-image? So AKA, we are looking for what our original points are. So let's go back up to the top. So we want to list the coordinates not only for A, but we also want to list them for B and C. So we know point A is -2, 4. We know point B is 1, 2. And point C is 1, 0. All right, so let's go ahead and look at number 16. 16 says, what are the coordinates of the vertices of our image? So what this means is we have to perform the operations that we have right here. We have to perform them on these coordinates. So what I'm going to do is I'm going to zoom out a little bit more. I'm going to go over to the side so that way that we can start looking at this. All right, so I'm going to perform the steps kind of over here, and I'm going to showcase them for every single point. So we know our original points are -2, 4, 1, 2, and 1, 0. So what it wants us to start off doing is it wants us to really subtract what our center of dilation is. So remember our center of dilation. So center of dilation, right, is -2, 4. So we have to subtract those values from each of our points. So think about this. Subtracting a negative is just going to yield to adding, right? So what we're going to do is we're going to end up adding 2 to our x value, and we're going to subtract 4 from our y value. So we're going to do that for every single one of these. So I add 2 to the x's, subtract 4 from the y's. So I want to rewrite my values. Well, what happens here is I have -2 plus 2. This gives me 0. So the first point, the coordinate for x is 0. Then I have 4. I'm subtracting 4. So the y value is going to be 0 as well. This makes sense because our center of dilation, we're changing it so it's the origin, and this is the center of dilation. The same thing won't happen here, though, so keep that in mind. All right, so next what we can do is we're going to add 2 to the x value, subtract 4 from the y value. So what we will end up with is 3, -2. We're going to do the same thing up here. We're going to add 2 to the x value, subtract 4 from the y value, and that's going to give us 3, -4. So these are our current coordinates after step 1. So that's something kind of to consider. That's after step 1. So now we have to go ahead and do our next step. We have step 2. So looking at this, we have to dilate or multiply each of these, all the x's and y values, by a scale factor of k. So remember, our scale factor, right, is times 2. So we're going to multiply these values, all the x's and y's, by 2. What happens with our first point is we still have 0, 0. What happens with our next point is we multiply 3 times 2 is 6, and 2 times a -2, which is -4. So I have 6, -4. And then the last one we get should be 6, -8. So those are our coordinates after our second step. All right, so it's looking good so far. Awesome. Okay, now we're going to go ahead and try our third step. All right, so here we go. We're going to go ahead and add back the initial translation. So we have to really do the opposite operation. So remember how we were subtracting a negative before? So write down, we're going to do the opposite of step number 1. So keep that in mind. So right now we're going to subtract 2 from our x values. So again, you might want to make note of that. So those are the x values, those are the y values. So here we're going to subtract 2 from our x values, and then we're going to add 4 for our y values. So now we're going to do that with every single one of these coordinates from here and rewrite what we have. So now if we subtract 2 from our x, we get -2. If we add 4, we get 4. All right, going on to the next one, we subtract 2 from 6, we get 4. we add 4 to negative 4, we get 0. And then last but not least, we have 6 minus 2 is 4. Negative 8 plus 4 is going to be negative 4. So right now, these are our ending coordinates. So what we're going to realize is that our center of dilation actually will stay in the same spot, even if it's not the origin. So that holds out. Everything else will change. It'll change because remember, it's not just being multiplied by 2, but we have a different center of dilation. So these are going to be the coordinates of the vertices of our image. So I'm going to go ahead and I'm going to draw an arrow to that. Awesome, awesome. All right, so now what it wants us to do is it wants us to graph our pre-image, meaning what we started off with. So if we go up above, right, up here, we can see right here, that was our pre-image. It wants us to draw that. But then we also have to draw the new image, which is these coordinates right here. So I'm going to have you pause the video right here, and I want you to go ahead and graph the pre-image and image on our dilation below in 2 different colors. So what I'll do is I'll do my first one in black and then my second one in purple. Go ahead and try that now. All right, so I drew my pre-image that I have here. I labeled the vertices A, B, and C. I know that I'm going to have A prime, B prime, C prime for my next or my image. So I decided to just show you those in purple before I connect each of the points with each other. But if you realize when you connect them, kind of creates this little bit of an extension. Right? This is pretty cool to see, right? So we can see that this triangle really is just kind of an enlargement of what we had before. So we have this tiny triangle that we had in black, and now we have this purple triangle right here. So that's cool to kind of see how our center of dilation works when it's not the origin. Now, in case some of you are thinking, oh boy, this is a lot of steps in one, what we can also do is we can use this formula and make a really quick shortcut on how to do this. Some of you actually might like this a little bit better. So I'm going to show you how we can use the formula. So I'm going to go ahead and show this down here. Again, we will get the same results. I'm actually only going to show it on one of the points. So let's just pick this point, 1, 2. So let's pick the point 1, 2, so I'm going to write it down for 1, 2. I'm still going to use the same center of dilation, and I'm going to use the same scale factors here before, and I'm going to use this formula right on up there. So what I can do is I can put 1 and 2 in for x. So I'm going to rewrite this formula. So that way I'm going to put 1 and 2 for x. So I have 1 and 2. I'm going to end up, subtracting out my A and my B value. So I'm going to end up subtracting negative or adding 2 and subtracting 4. So I'm going to add 2 minus 4. And following our pattern, we put parentheses around that. We want to make sure we do that first. Then we multiply by our scale factor of 2, our K value. So I multiply by 2 up front. And then last but not least, we have our last step up here where we're going to add back in what we subtracted or, do the opposite of what we did before. So we added 2 here. We're going to subtract 2 on the outside. I subtracted 4, so I'm going to add 4. So if we follow this formula and follow, order of operations, we can actually get the result of 4, 0. So let's go ahead and look at this. So we do what's inside our parentheses first. So we're going to do 1 plus 2, that's 3. We're going to do 3 times 2 first, which is 6, and then do 6 minus 2, which is 4. That is our x value, so let's keep going with this. Let's try our y value. So I'm going to do 2 minus 4, that's a negative 2, and then I have to make sure I multiply that by 2 first before adding 4. So 2 times a negative 2 is negative 4. When I add 4 to that, hey, I get 0. Hey, this checks out with the same thing that I got over there. So we're just taking all the steps that we went through and compiling into a nice little formula. So we'll get the same results either way. Now, I know the textbook doesn't have a lot of other problems like this where you get to perform, a full dilation with a scale factor and a different center of dilation than 0. So what I'm going to do is I'm going to come up with a problem for you to practice on your own. So go ahead, find some space maybe in your textbook. You're definitely going to have to graph and show a little bit of math, or if you want to find a blank sheet of paper or a blank document in Notability, go ahead and pull that out. Alrighty, so I pulled this problem up from last year. That was a homework assignment, but I want us to try to do it together. So I want us to complete the transformation of the triangle below. So you have to sketch the pre-image with the given vertices right there. So I have my graph to kind of help me out with that. Then we have to find the coordinates of the image after a dilation of 1/4. So think about what that means. Is it getting bigger, smaller? What is that meaning? And it's going to be around our center of dilation of 1, -3. So this time, our center of dilation is not one of these coordinates. So keep that in mind. Then after we do that, we have to sketch the image on the same graph. So I want you to go ahead, pause the video right here. I want you to follow the same steps that we just went through. I'm going to go ahead and do the same thing, and then we're going to compare our answers at the end. Alrighty, so here's exactly what I got for this problem. You can see that I had in green, I sketched the vertices. Now, I didn't give you letters for them, so you didn't have to label the vertices, but sometimes it's helpful to do that. But as you can see, each line on this graph is worth 1 unit. I decided to make an X, Y axis. So then here is my math below here showing what I exactly did. So I know that if this is my center of dilation, I have to move it to the origin, 0, 0, by subtracting 1 and then adding 3. So that's what I first did with this first set of coordinates. I subtracted 1 from the X value, added 3 to the Y value. This is what I should have gotten after step 1. So I'm going to go ahead and write that down. So this is what you should have gotten after step 1. These values right here. Then after step 2, where we multiply by the scale factor of 1/4, or as we know, 0.25, making our image smaller, right? So this is going to be our, let's try that again. This is going to be our step 2 right here. Looking awesome, looking awesome. All right. And then our next step down here is for our X values. We have to do the opposite of what we did before. Instead of subtracting 1, I add 1 to the X values, and then I subtract 3 from the Y values. So that is going to be our last step. That is step 3. And those are now the values of our image. So we can see that it actually shrinks when we put this on the board. Now, we didn't have one of these points that was exactly on our center of dilation, right? We had a different point that was a center of dilation. It was 1, -3, so it was 1, -3 down here. So that's kind of what we're centered around. So that's why it looks a little bit different from the other example that we did. All right, nice job, geometry students. Great job going through this problem. If you have a different teacher than me, check in with your teacher on what your homework is going to be for today. I know for my students, it's just watching this video and taking notes over it, and then we're going to talk about it more in class tomorrow. All right, have a good rest of the day. Bye.